Hello children, good morning to all of you. In this video, we have to discuss about the numerical problem related to the current electricity. In the first numerical, see, a current of 0.2 ampere flow through a resistor connected with a DC source of 3 volt. Calculate the resistance of the resistor. So first you see in the numerical what is given and write with symbol. A current of 0.2 ampere is given. So first you write I equal to 0.2 ampere and connected with a DC source of 3 volts. So potential source of DC is given of 3 volt. Now find out the resistance of the resistor. So according to Ohm's law, everyone knows V equal to IR. So R equal to V upon I. Now put the value of V and I. V is given 3 volt upon current is given 0.2 ampere. Now solve it. It is equal to 30 by 2 and that is 2 15 30 and it is equal to 15 ohm resistance. Now see the second question. A wire is stretched to n times to original length. Calculate its final resistance. So, to see the solution, first we consider the initial length of the wire is L and final length becomes L dash. But according to the question, the final length becomes n times of the original length. So if final length is L dash, initial length is L, so final length becomes NL. And we have to consider the initial cross-section area of the wire is A and final area of cross-section becomes A dash. When length is increases, then thick wire is converted in a thin wire. And we have to consider the initial resistance of the wire is R and final resistance becomes R dash. But specific resistance in the both cases it is remain constant because it is depend on the material. So in this process material is remain constant. Now write the relation. Everyone knows R equal to rho L by A. So for the first condition, initial condition, resistance of the wire is R equal to rho L by A and final resistance R dash equal to rho is same L dash upon A dash. Equation second. Now divide the first and second equation. Rho is cancelled and now R upon R dash equal to L by L dash into A dash upon A. So the relation between L and L dash, everyone knows, L by L dash equal to L is given L, initial and final length is NL. So L is cancelled and it is equal to 1 by N. Or L dash upon L equal to N. Now find out the relation between the cross-sectional area. If wire is stretched, then no effect on the mass, and everyone knows mass equal to volume into density, and density of the wire is depend on the material of the wire, so density is remain constant. So initial volume of the wire is equal to final volume of the wire. And wire, the nature of the wire is just like a cylinder. So everyone knows about the volume of the cylinder. Cross section area A and initial length is L. AL is the volume. Initial volume, it is the final volume, A dash L dash. So A upon A dash equal to L dash by L. And relation of between L dash by L is N. Now according to this value, we have to find out the relation between the resistance. So relation between L and N dash is L by L dash. If L dash by L is N, so L by L dash is N into A dash by A is also equal to L by L dash, where L dash by L is N, so L by L dash is 1 by N into A dash, A by A dash is N, so A dash by A is also 1 by N and it is equal to 1 by N square So R by R dash equal to 1 upon n square. So R dash equal to n square R. So if Y resistor is n time, so the final resistance becomes n square time. Just like if a resistance is given 2 ohm, initial resistance is given 2 ohm, and Y resistor is 4 times, then find out the final resistance. So R dash according to this relation 4 times, so n equal to 4 square into initial resistance 2. 4 square is 16 into 2, and it is equal to 32 ohm. Thank you.